So as a systems engineer, you do a lot of trade studies and a lot of design architecting. So one of the very first things that comes to mind is when you're trying to solve a technical problem. So, and all technical problems are interrelated between the subsystems. And so you have to look at a technical problem and you have to think of many different approaches in which you can get to a solution. So thinking in multiple dimensions is always understanding there's multiple approaches on how to get to the solution and being able to trade those and look at those. There's the technical aspect, but then as a systems engineer, you also have to take a look at some of the programmatics too. There's things like cost and schedule that do impact the ultimate decision that's going to be made by the project manager or the program manager that you're working for. And so also thinking that aspect of decision making and, you know, how that impacts your solution. You might have multiple solutions and one is more costly, one takes more time. You have to be able to understand the sensitivities from a programmatic standpoint too, and be able to weigh those into your decision making. So multi-decision making is having a trade space with multiple approaches. It helps you look at a solution more in depth and more rigorously. And I believe it allows you to have a broader understanding of all the complexities of what you're trying to solve. And it gives you a better solution in the end. So early on in my career, I recognized that I was able to see at a bigger picture. A lot of engineers are very detail-oriented, and I was always able to see things at a bigger picture. I was able to listen and understand the other interfaces to my subsystem and understand how the other subsystems impacted the work that I was doing. And once I recognized that I could do that, I kind of became more interested in what was happening at a bigger picture level. And I started getting more experiences. I have a lot of different experiences. I have a lot of fluids background. I have a thermal background. I have, a systems background. I've done propulsion systems. I've done power systems. I don't have a lot of detailed, in-depth knowledge about all of those things, but I do have a pretty good understanding on how all of those things work together, how the interfaces between those different things impact each other, and being able to see that and understand it and continually to use that. I can think of one time when I was working on a smaller spaceflight project early on in my career, and I was the systems engineer, and we integrated our payload down at KSC, and the software guys were having a really hard time because their software wasn't working. And I kind of walked into the room and I was listening to them, and I looked at them and I said, I think your software is fine. I said, I think we wired this incorrectly. It's not a software problem, it's a wiring problem. And we brought the avionics team in, and sure enough, one of the cables was wired wrong into the system. But it was that ability to look and think, well, this isn't a software problem, it's an avionics problem, it's a wiring problem, and being able to recognize that and think at a multi-discipline level instead of just at a single discipline level. And so it's a lot of experience. It's a lot of getting a lot of different experiences. I think it's really important for anybody who wants to be a systems engineer is just putting yourself out there. It's hard because you don't know all the technical details, but being comfortable enough to learn at a higher level how things interact and play with each other. So seeing in multiple dimensions means having to navigate through a lot of complexity. And so one thing that I tend to see happen is when you're trying to think multidimensionally and you start getting down into too many details. There's, there's you're a fluid systems engineer and you start digging into the fluids aspect of the problem and you start getting down into these details that are making the complex problem even more complex. And that's not what you need to do. You need to use your ability as a multi-dimensional thinker to break things down into different elements, be able to understand how the elements are tied together, and then how to take all of those different facts and details and come up with a solution. And so you can get yourself wrapped around a complexity issue of the complexity of the design, the complexity of the technical details in being a multidimensional thinker. And so that's where you have to sometimes pull yourself back, think more broadly, pull yourself out of the details or the team that you're trying to facilitate. That's what I generally have to do is I have to take the group of engineers that I'm trying to facilitate and say, we're getting down into the weeds. We need to pull ourselves up. We need to start thinking more broadly, or we're never going to come up with a solution. We're creating a more complex problem than we really have. So what I would tell them is put yourself out there, get different experiences in different technical areas and also different experiences dealing with different programmatic aspects. Understand the differences and how the subsystems interrelate. Put yourself out there to be the person who is communicating with other subsystems, who is bridging that communication gap, both technically and programmatically with other subsystems. There's two different aspects. The one that engineers generally do well, which is getting the facts and getting all that detailed information and pulling that together. Multidimensional thinking is also having vision and intuition. So as you get to be a more senior engineer, you have intuition. You just know, when solutions are better vetted. You know when you feel like you've discussed and brought in all the stakeholders. You have a better vision of where things are going. So put yourself into those situations where you can do this.